Now we will start today's class with a brief review of what we have done so far in this chapter. Probably today I will finish this chapter. In the next class, we will have a problem solving session from this chapter. We started this chapter with the definition of a continuous random variable. We said a continuous random variable is a variable that can take uncountably infinite number of values. We defined the PDF of continuous random variable, the CDF, the mean, the variance, and the percentiles. Then we started moving towards the special distributions. The first special distribution that we discussed was an exponential distribution. The application of exponential distribution lies in time until failure, time until success. One of the important things that we discussed in exponential distribution was that it has no memory. It has a memoryless property. So whatever happened in past is happened. You can forget about that and find the future probability without considering any memory of the variable. The second distribution we discussed was an extension of exponential, which is called Weibull distribution. For both of these distributions, the good thing was that the functional form of their CDF was available. This was helping us finding the probabilities and percentiles. But then we moved towards the third distribution, which is called normal distribution. Although the functional form for the PDF of normal distribution is available, but if you integrate this function, it doesn't give you a closed form solution for the CDF. And hence, we say that the CDF of normal distribution cannot be presented as a function of x in the closed. That is why we move towards the tables. But when we started thinking about moving towards the tables, we thought, how many tables can we make? Can we make a table for each possible value of mu and each possible value of sigma? The answer is a definite no. So instead of making infinite many tables, we came up with a solution that let's standardize every normal random variable to a unique standard normal random variable, and then convert every question of normal distribution to standard normal distribution, and then go to a unique table, which is for standard normal distribution, and solve any question. So now if you encounter any question related to normal distribution, the first step will always be to convert it to standard normal distribution by subtracting the mean and dividing by the standard deviation. Then you can go to the standard normal distribution table to get either the probabilities or the percentile, whatever is required in the question. So let us have a look at the same example that we did last time. We were doing this example which says that suppose the current measurement x is assumed to follow a normal distribution. Mean is 10. The standard deviation was 1.5. The first question says find the probability that measurement exceeds 13. So probability of x more than 13 was required. Now, as you can see, the first step I did is I converted x into z. Converted the normal into standard normal. So I subtracted the mean divided by the standard deviation. Once I was into the z, the second thing I did is that z table is available for less than probabilities. It is available in CDF form. The table for z is available for the CDF. If you look at the table, let me show you. Right at the beginning of the table at the top, you will see an expression. Here, can you see it? This is clearly telling you that this table is for what? For less than probability. So if you have any question of probability or percentile, you first have to convert the question into z, then you convert the equality into less than. First convert it to z. If the question is greater than, use the complement rule to convert it to less than. If the question is in between, convert it to less than. So after converting the z, then the next step should be to make the inequality less than. And this is what we did in this question here. The question was greater than 1.5. I used the complement rule to make it less than. Once this is less than, now this probability of z less than something can be directly found from the table. the last thing we discussed was that the values of z, these values of z in the table, they are available up to how many decimal points? 2 decimal points. Probabilities are 5 decimal, but the values, these values are 2 decimal. This probability, the answer is 5 decimal, but the values are 2 decimal. If you encounter a question where this value rounds up to more than 2 decimal points, what you do is you round it to 2 decimal points to look into the table, the usual rounding.
Yes. Z equals to 1.5. What's the difference between this term?
For any continuous random variable, whether it is exponential, Weibull, normal, standard normal, log normal, or any unknown continuous random variable, the probability of variable equals to something is 0. Any continuous random variable. Whether it's a general case or exponential or Weibull or normal or log normal, any continuous random variable, the probability of z exactly equal to 1.5 is 0. Always 0. Okay. So whether you contain equal sign here or you don't contain equal sign, it will not matter for any continuous random variable in general. Then again, we followed the same pattern. The next question was asking me to find the probability of x between 8 and 12. Again, step number 1, I converted x into z. Step number 2, I converted everything into less than. Once everything was converted into z and less than, I looked into the table for the 2 probabilities and solved the question. The third question was the other way around. In the first 2 questions, I was given the value of x and asked for the probability. Now I'm given the probability and asked for the value of x. So this is the reverse use of the table. That means you will look inside the table for 0.98 and your answer is at the edge of the table, which is the value of x. So we converted again this guy into z. And after converting it into the z, we looked into the table and the value was 2.05. We compared these 2 equations to come up with x equals 14.1. Now we'll quickly do these couple of questions and move on towards the last distribution. This question says, what is the probability that the measurement is within 2 standard deviation? Read the question again and try to see what exactly is the question. Yes.
+2 and deviation -2.
Yes. The question says that what is the probability that the measurement is within 2 standard deviation of the mean? So we're asked to find the probability that x is between mu minus 2 sigma and mu plus 2 sigma. Now, if you, again, the same steps, no difference. Convert this question into standard normal. So if you convert it to standard normal, this will become minus 2 z plus 2. Make your calculation and see it. When you subtract mu, mu will be cancelled. When you divide by sigma, sigma will be cancelled, and you will be left with only minus 2 and plus 2. Subtract mu from all 3 sides. Minus mu here, minus mu here, minus mu here, mu will go out, right? Then you divide by sigma on all 3 sides. Sigma will be cancelled, and you will be left between minus 2 and plus 2 for the standard normal z. Then convert this question into less than. What is the probability of a variable, continuous random variable between a and b? It is less than b minus less than a. Finally, go to the z table, get these 2 probabilities and put them into the equation. So we go to the z table. Here is the z table. What is the probability of z less than minus 2? Plus 2 first. Plus 2. 2.00. 0.97725, right? 0.97725. 0.97725. And for minus 2, 0.02275. 0.02275. So it becomes 0.97725 minus 0.02275 and subtract, get the answer. 80% of the current measurements are higher than what value? What is this required? 20th percentile or 80th? You have to specify. I'll show you the diagram now. This is the normal distribution, the one that we are solving the question for. Here is minus infinity and here is plus infinity. And you have to find a value of x such that 80% of the current measurements are higher than that value. Where is that value? That value is here. Such that this area is 80%. And this value is the 20th percentile. As we can see it from the diagram, 20th percentile is the value of x such that 80% of the measurements are higher than that value. Read the question. 2 times, read the question loud. 80% of the values of x are higher than what value? So you have to find a value such that 80% of the values are higher than that. It's 20th for this value, 20th percentile. This is actually P20. So you have to solve this equation. Probability of x less than equal to a equals 0.2. Solve for a. Again, the same thing. You will convert this to z. When you convert this to z, a minus the mean was 10. 10? Yes. 10 divided by call this equation 1. Now go to the table and look into the table that what is the value below which the area is 0.20000. And you will not find an exact value, you will find an approximate value. So we'll try to find a value such that the lower tail area is 0.20000. It's either this one or this one. Which one is closer? This one distance is 34, this one is 45. This one is closer, is it? This one is closer. This one is closer, and it is minus 0.80, 1, 2, 3, and 4. Minus 0.84. So the table tells you that the probability of z less than minus 0.83 or 4. 4 is approximately 0.2. You have one equation from the question, one equation from the table. Equate the two of them, what do you get? You get a minus 10 over 1.5 equals minus 0.84, and this gives you the value of a. Now here is another conceptual thing I'm going to tell you. When you had a question in terms of x initially, correct? What did you do? You converted into z. You standardized it. After standardizing, you got the answer from the table, minus 0.84. After getting the answer from the table, here you are de-standardizing back to x. The initial question was in terms of x. You converted the question of x into z. Why? Because the table of x is not available. You cannot make a table for every x. You converted the question into z. You solved the question in terms of z, and the last step is to convert back to x. When you convert back to x, look what you are doing. You are actually adding the mean instead of subtracting. You subtracted the mean, you will add it back, and there you divide it by the standard deviation. Here you will multiply it back. Look at the expression. Your a is minus 0.84 times 1.5 plus 10. What are you doing? Whatever you did, you're reversing that. You subtracted the mean here, you are adding it back. You divided by the standard deviation here, you're multiplying it back. So this step is called standardization. This step is called de-standardization, converting back to the actual units of x. Clear? Now, one of the properties of normal distribution is that it is a symmetric distribution. Maybe there are some questions asked about the symmetry of the distribution. By the symmetry of the distribution, we mean the following. Here I will write some expressions and you will understand what do we mean by symmetry. By symmetry, I mean probability of z less than -2 is equal to probability of z greater than +2. Whatever is on the left side of 0, mirror image is on the right side of 0. I'll show you this thing through the diagram. If your standard normal distribution is something like this, where is -2? Here is -2. Where is +2? Here is +2. So the standard normal distribution symmetric property says that this area is equal to this area. Sometimes you might get a question that asks you to use the symmetry of the distribution. Similarly, probability of z greater than -2 is also equal to probability of z less than 2. That means this area is equal to this area because of the symmetry of the distribution. So whatever is on the left side of 0, imagine the mirror image is on the right side of the 0. Exactly the same mirror image. So these two equations, you might be forced to use these two in some question, where we give you probability of z less than -2 and ask for probability of greater than 2. So you can use the symmetry and say that this probability is the same. Any questions? Let us move on towards the last topic of this chapter, which is an extension of normal distribution and nothing new. This is called a log normal distribution. I will tell you exactly where are the tricks and where are the issues. A log normal random variable, it's a random variable which is said to follow a log normal distribution if your variable is e to the power w and w is normal. If w is a normal random variable, then e to the power w is called a log normal random variable. The mean of log normal random variable is denoted by theta, and the variance is denoted by omega squared. Now, where is the issue? Again, the issue is that this random variable does not have a closed form for the CDF. Again, you will have to use the table. But which table? Now you will convert it first to normal, because this is e to the power normal. To convert it back to normal, you will take the log of this one minus its mean divided by its standard deviation, and it will convert back to z. And then go back to the same z table and get the probability. Where is the trick? The trick is here in its mean and variance expression. Remember, log normal distribution is standardized by its theta and omega. Did I say mean and variance? No, I will update this one. Its mean is not theta. Its mean is a function of theta and omega square here. Mean is this one and variance is this one. Now, the trick that you might get in exam is that instead of giving you theta and omega directly, we might give you the mean and variance. For the normal distribution, how do you standardize? For normal, z equals x minus mu divided by sigma. For log normal, Z equals log of X minus not mu minus theta over omega. Now we might not give you theta and omega directly. We might give you mu and sigma of log normal and ask you indirectly to find theta and omega. How? Here, solve these two equations. I will give you mu equals, let's say 10 and sigma equals, let's say 1.5. You have to solve these two equations to get theta and omega. Once you have theta and omega, you will plug into this standardization formula to convert the question into Z. Again, log normal is nothing new. You have to convert every question of log normal into standard normal. How? Using this formula. And that's it. It's just the change of the way you do the standardization. Other than that, everything is the same. Everything is the same. Not a new distribution.
What is the EXP?
Where?
EXP.
E to the power.
Oh.
EXP means E to the power. I don't know if they use the same thing in your formulation. No, in the formula sheet, they write E to the power. So in the formula sheet, this is written like this. E to the power theta plus omega square by 2. And similarly, this one. Now let us try to see some of the questions from log normal distribution. Read the question. The question says that the lifetime in hours of a semiconductor laser follows a log normal distribution. Again, there will be no question in exam where you will be asked to guess what is the distribution, if it is log normal or not. A question from the log normal will mention that X follows log. It follows a log normal distribution with theta equals 10 and omega equals 1.5. This is an easy version of the question where we directly give you theta and omega. So very easy standardization. So how do we solve this question? What is the probability that the lifetime exceeds 10,000? So probability of X bigger than 10,000, this is required. Very simple question. You have to convert X into Z. So I will convert this X into Z. This is probability of Z bigger than log of 10,000 minus what is theta? 10. What is omega? 1.5. And this is it. This is probability of Z greater than greater than minus 0.53 minus 0.53. Can you get this probability directly from the Z table? Can you get this probability directly from the Z table? No. You have to convert it. Or you can also get it directly. Is there a way to get it directly? Symmetry. Use the symmetry of the distribution to get it directly. So you can call this one to be equal to, this is a tougher way, but a shorter way. This is equal to probability of Z. This is greater than less than 0.53. You switch the equality and sign together. So this is another way, a shorter way, but a difficult way. The easier way is to just convert it into less than. So this will be 1 minus Z less than minus 0.53. You go to the table, look for minus 0.53 minus 0.50, 51, 52, 53, 0.29806. 0.29806. So this is 1 minus 0.29806. And subtract from this 1 minus and you will get the answer. Or you can get it directly, z less than minus 0.53, plus 0.53, and that would be plus 0.53, plus 0.53, 0.501237, 70194, 70194, which will give you the same answer, the one I got here. Seven 70194, right? Right? So either use the symmetry or use the complementary. Both ways, you get the same answer. What lifetime is exceeded by 9? Again, the confusion here is question is about first percentile or 99th percentile. Yeah, what is the value of x that is exceeded by 99% of the values? What if the question says what lifetime exceeds 99% of lasers? 99. So be careful with the identification. The biggest confusion comes with exceeded by and exceeds. So practice with these two words. Here the question is what lifetime is exceeded by 99%. So the question is something like this. Here is the distribution of all the lasers. And they are asking you to find a value of x such that this value is exceeded by these 99%. So they are asking you to find the probability, not the probability, the value of x such that the probability of x less than that value is 1%. Again, convert it to z. But because x is log normal, you convert it to z using the log normal conversion formula, which is over omega less than a minus theta was 10 or what? Yeah, 10, yes. 10, omega was 1.5. Yes. And this is equal to 0.01. So now you have probability of z less than something equals 1%. Go to the table, and the table will tell you that probability of z less than 2.33 is 1%. From the table, probability of z less than minus 2.33 is 1%. So equate these two. What do you get? Here I made a mistake. Nobody noticed. Did not take the log. Right? So finally equate these two. What do we get? We get log of a minus 10 over 1.5 equals minus 2.33. This implies a is 68.48. How will we solve this one? Step by step. Multiply both sides by 1.5, then add 10 to both sides, then e to the power both sides. Again, I repeat, multiply both sides by 1.5 first, then add 10 to both sides, and finally take e to the power on both sides, and then you will be left with only a on the left side. Get it done yourself. The way of converting it to z. Yes. Log normal is positive, only positive. What is log of minus 150? Positive.
So it's on the
Log normal is on positive scale.
So it can't be on the.
No. Here, look. The log normal random variable is a positive random variable because log of anything is always the positive. Sorry, not log of e to the power anything is always positive.
So
Yes.
when we state it normal or normal,
It will mention clearly that variable is normal or log normal. Clearly, the word normal or log normal will be in the question. Now, here is the difficult. No, this is part 3. Determine the mean and standard deviation. This is again simple question. That is, these expressions are given to you. Theta is given to you. Omega is given to you. It's just a game of calculator. You have to plug theta and omega into the expressions and get the mean and variance. This is easy. But the tough part is if the question is given to you in this way. It's the same question, but I gave you in a different way. And this is where you will make mistake. Many of you will make mistake. And many of you will do something like this. Read the question and I will tell you what mistake you make. It's the same question. The question says that the lifetime X of a semiconductor laser follows a log normal distribution with mu equals 10,000 and sigma equals 20,000. Forget about this. Directly, look, the question asks you, gives you this, asks you this. This one is missing. For now, forget about this. Read the question. The question says that lifetime follows log normal distribution. Mu is 10,000, sigma is 20,000. Find the probability that X is more than 10,000. This is the mistake most of you will make. Number one, you will know that probability of X more than 10,000 is required. This is okay. But some of you might write it like this. Confuse it with Z. Wrong. Number one. Number two, some of you might do it like this. Wrong. What is the idea? You have to solve those two equations for mean and variance to find theta and omega. Remember these two, the difference between normal and log normal. Remember, normal is standardized by its mean and standard deviation. Log normal is not standardized by its mean and standard deviation. It is standardized by its theta and omega. Remember, if for this question we give you mean and standard deviation, you must find theta and omega by solving the two equations simultaneously. Go and do practice solving those two equations simultaneously. Those two are not very easy equations to solve. Those equations are not easy to solve. So go and practice. If we give you mu and sigma, how to get theta and omega from those two? By solving which two equations? These two equations.
Do you have an example of the variance of this?
Yes, I will give you one next class when I solve the questions, because I know in last semester major I gave this. I will solve for mu and theta. So in case 2, this was the trick. Then if you are able to find mu and theta, then standardize it this way. This is the correct way. And the thing I did is I solved it using this way, and these two answers were there in the choices.
Here, we also have to have
Yes, at the end. Yes, for all the cases, at the end, of course, you will do 1 minus. To use the z table, of course, you will do 1 minus. So the correct way again is to number one, you might miss taking log. Number two, you might use the wrong parameters to standardize. Instead of standardizing by theta and omega, you might standardize by mu and sigma. Log normal is never standardized by mu and sigma. It is always standardized by theta and omega. Normal is always standardized by mu and sigma. So that's the major difference between normal and log normal. Number one, two differences. Number one, for normal, you standardize x as it is by subtracting mean and dividing by the standard deviation. For log normal, you standardize number one by theta and omega. Number two, you take the log of it, not without taking log. This is what will be given to you in the formula sheet. Now let me wind up the class.